In this must listen episode of the Enterprise GTM podcast, I dive deep with two powerhouse AI experts, Manasi Vartak, who's Chief AI Architect at Cloudera, and Shreya Shankar, who's a PhD candidate at UC Berkeley. In this episode, we talk about the state of generative AI within enterprises, why are less than 10% of GenAI projects reaching production lately, the crucial role of user experience when embedding generative AI into enterprise workflows. We discuss some of the fascinating work that Shreya is doing in the realm of applying generative AI for data engineering and why the next unlock of AI will come from proprietary enterprise data and domain specific AI tools. If you're building with AI, leading enterprise teams, or navigating data engineering challenges, this episode is packed with real world insights and actionable takeaways. You don't want to miss it. Great. Welcome to yet another episode of the Enterprise GTM Podcast. Today, I'm super excited to have not one, but two amazing guests who are experts in the field of AI. So here, without much further ado, we have Manasi. Manasi Vartak was the founder and CEO of Vartak. It was a venture-funded startup, an operational and AI and LLM platform, which she exited to Cloudera. Manasi invented experiment management and tracking while she was at MIT, where she created Model DB, which was the world's first open source model management system, and it was deployed to several Fortune 500 companies. After earning her PhD from MIT, Manasi went on to data science positions at Twitter, where she worked on deep learning for content recommendation, and Google, where she worked on dynamic ad targeting before she started Vartak. Today at Cloudera, Manasi is Chief AI Architect. Welcome, Manasi.
Thanks so much for having me. Super excited to be here.
Awesome. And our other guest is Shreya. Shreya Shankar is a fourth-year PhD student at the University of California at Berkeley. Prior to her PhD, Shreya was an ML engineer. She completed her bachelor's and master's in computer science at Stanford. She builds systems that help people use AI to work with data effectively, regardless of their technical background. Shreya, welcome to the podcast. You're doing some amazing work. We're really excited to talk to you more about all that.
Thanks, Vidya, for having me. Excited to talk about it too.
Awesome. Well, you're two phenomenal people who come at this AI and Gen AI space in general from two different vantage points, even though you both have a lot of commonalities in your background. To start with, Manasi, you have a very unique position at Cloudera where you get to see many enterprises, and some of them, I'm sure, are very, very big. And in terms of like productionizing their own homegrown Gen AI applications, what do you see in large enterprises as we speak today in December 2024? How much appetite is there for doing something like that? We all know that just a few months ago, especially in the beginning of the year, late last year, there was a ton of excitement and it was obvious why that was the case. Where are things right now?
Yeah, the excitement about GenAI has not died down, which is good for us working in the space. I think the space is also very early, so we have long ways to go. At the beginning of 2024, there was this sense that 2024 would be the year of productionizing GenAI. I think we're quite early in that journey, even now, from what I've seen. What I see across the board is I think there is a greater appreciation for what it takes to build a production grade GenAI application beyond just I built a demo at a hackathon and it's so cool versus it's going to work 95% of the time. It's going to respect data, security, privacy, all of those things. So I'd say the adoption has been in production is still fairly slow. The percentage, I want to say, is less than 10% that have actually made it to production. And more companies are getting, I think they're getting stopped by their CISOs and their IT teams with respect to data privacy and security, because now there's a realization that we're actually sharing sensitive data with third parties. They might log that data or they might use it to train their own models. And so I'm seeing very deliberate decision making on whether new AI tools should be used, which is not to say that all of the experimentation is still going strong, but the barrier for putting something into production is still fairly high.
And that seems to be pretty consistent with what we're hearing from others in the industry too. So just the realization that there is a lot more work that needs to be done in getting something from prototype to production, as well as the security that is needed before big enterprises deploy things in production. What are some common use cases you're seeing, Manasi? Like, especially something that I'm curious to understand is, things that bubbled up to the very top when it comes to enterprise adoption of Gen AI. One of them seemed to be customer service use cases, the desire to automate away a lot of those kinds of tasks, if you will, if not entire jobs. Is that one of the top use cases? If not, what else are you seeing in like the 10% that is getting productionized?
100%. What we're seeing generally is that the RAG pattern, I'm going to call it, is still the number one successful use case I see deployed because it's easy to build. We understand kind of the parameters or the knobs that you can tweak to improve its accuracy, things like that. And then RAG can be applied in a variety of ways, whether it's simple sort of document search on your Confluence type of systems or your legal documents, you're doing search on them. Support is a major one that we've seen folks use RAG very successfully. I think the difference is, and I interact mainly with large enterprises who are fairly security conscious or are in regulated industries. So this is not, let's call it fast fashion retailers or that type. This is more energy companies, financial services companies, and the sort. And for that category of customers, it's internal facing applications, even now, where AI is being used the most. And it's places where there is a human in the loop that's providing oversight. So the support team might use it to triage the kind of support cases or to summarize the kind of support cases, and it's augmenting these humans versus having your support bot automatically resolve a case and interact with a human. There's still a degree of very high barrier or bar for that type of direct customer interaction that, at least in large enterprises, has yet to be crossed.
That makes a lot of sense. So it sounds like even of the 10% of use cases that have made it to production, a majority of them sounds like they're all still internal enterprise use cases. I mean, you call them rack pattern, but essentially these are use cases that are still in terms of what maybe HR wants or customer service wants or generally employees want, like in terms of access to knowledge and things like that, and much less customer facing. Is that right?
Yes, I would say so. At least for the largest of enterprises, that's very much true. And I personally think that's a good idea. It's a crawl, walk, run. You figure out if something is working. For the low risk use cases, build confidence and then go from there. The customer support and service one, there are startups that are doing this externally, and it looks very promising. So excited to see where that goes.
Yeah. And Mansi, you've been in the AI ML space for a really long time, and in fact, started in ML. And, of course, the industry has been evolving and transforming itself. Are there any parallels that you're seeing in terms of like, especially this progression from internal to external use cases and some of the challenges, including, of course, with LLMs and security, it's a different kind of challenge that we're having to overcome. I'm asking this question about what you see as parallels primarily because I'm trying to see what, if any, lessons we can draw from the past and how should we think about how this is likely to evolve in the future. So any thoughts on parallels here that you see?
Yeah, happy to give you my 2 cents. I've seen the transitions from data science to actually analytics in the good old days of histograms and things like that, to data science, to machine learning, to deep learning, to Gen.AI. Now it's agents, and then frontier AI that we haven't even imagined. So there are a few things that I would say are clearly different. Maybe I'll start there this time around. Is I've never seen AI to be so democratized before, even when it was deep learning. So if you think about AlexNet or the even BERT type things, I've never seen it to be so democratized. And that's really exciting. You have folks who are not deep experts in ML use these techniques and build on top of that. And I know Shreya does a lot of work on how do you make sure all folks, regardless of technical background. So that's very unique. Never seen that before, which means you need different tools for these category of builders. The other thing that's so different this time around is that these results are not exact. You could argue that ML also gives probabilistic results, But for this one, because it's language, it's not a yes or a no, how to take a result and make it consumable by humans or have humans build confidence on it, I think it's fairly unique. In terms of parallels between the ML waves in the past and now is as we're seeing now, folks are realizing it takes a lot to productionize. There was, I forget the exact thing, is like 80% of projects do not make it to production. That was like, and I don't think anyone knows where that number came from. It was probably a guesstimate, but fairly accurate. I'm seeing that.
This was in the previous world, right? I mean, the
yes.
80%. And it's interesting. I also wonder, by the way, sorry to interrupt, but I was wondering, where is that number these days? Like, we're talking only about Gen.AI, but I also wonder where that ended up.
Yeah. And we're talking about Gen.AI right now, but most of the use cases, I want to say 50% of the use cases are still traditional ML, because that's the structured data that exists, so on and so forth. But folks are realizing how hard it is. It's not a silver bullet. It's not as easy as, I just plug in ChatGPT and it's done type of thing. So that's very similar as, you need data pipelines. You need good evaluation suites. You need to figure out UX, something we're going to talk about more. So those are similar to what I've seen in AI ML before. Eventually with AI ML, what we've seen is a lot of the development of models has been in-house eventually. Like folks are building their own fraud models or they're building their own recommendation models on their enterprise data. We're seeing that slowly with GenAI because the foundation models are already trained on the public internet. So we've tapped out or we're close to tapping out the publicly accessible information. So the next unlock seems to be the enterprise data, which is kind of similar to AI ML, where the truly useful models came from your enterprise data. So that's a parallel. We haven't yet crossed that, but I suspect that that's going to become more common. The one thing that's different, though, is we're going to see every application that an enterprise uses, whether it's customer service, it's recruiting, it's legal, is going to have AI built into it in a very significant way. With previous machine learning techniques, we didn't see enough of that. But this time around, I think that's going to be the case. So those are some of the parallels and also differences that I see. And yeah, would love to have you folks also weigh in on that.
Yeah, those are great points. And I think, good segue into Shreya. I mean, Shreya, you're doing some amazing work here. Tell us a bit about your area of research, and please anchor the audience here on what you do, and please also touch upon DocETL.
Yeah. So I'm a PhD student in the database group at Berkeley. And I think the best way to think about this is the high-level vision. GenAI is incredibly powerful, and it's enabling a world where anybody can make sense of any amount of data, any type of data, any user, technical person, non-technical person. It's reimagining the query layer. People are writing natural language queries, converting them to SQL to run on relational databases. It's reimagining what's possible with GenAI. So you can imagine having AIs scan your data, having that kind of operator in your database. And then now you can get completely new types of analysis. You can get summaries, all sorts of unstructured data analysis. And DocETL is kind of our vehicle to help us achieve this vision. So I think right now the main research focus is for us to reimagine what does a database architecture look like in this world where GenAI is front and center, helping people make sense of their data. So we have an interface layer where we're thinking about what are the right kinds of operations that people are going to write. A prompt is extremely expressive, right? You can ask anything and everything in an LLM prompt. And this is very difficult to make sense of. So what are the right kinds of operations here that are fundamentally prompt-centric? At the optimizer level, all databases have query optimizers. How do we redesign an optimizer to account for the fact that LLM prompts are not always correct? In traditional databases, when you rewrite query plans to be more optimal, you know that all of your rewrite candidates are correct, right? If you push down a predicate, that's going to give a correct plan. But when you rewrite an LLM-based query plan, you might accidentally have a more inaccurate plan or a more accurate plan. So, right, how do we have accuracy optimization built into the optimizer in addition to traditional efficiency-based, latency-based cost optimization. And then, of course, the storage level, right? What does it mean now to have the data lake? Not everything is relational data, right? So we have to support all of this kind of data. So that's kind of the high level vision of the DocETL project. We just have a paper out on the query optimizer and, of course, just the system. We're working a lot now on the interface, the no-code UI. That paper will hopefully come out soon. And then I think there's a lot more work that we can do in the systems layer. I've been talking to a lot of people who are working on GenAI in relational databases. So what are the kinds of optimizations that can enable both relational or take advantage of the relational model too? That's something we didn't explore in our original preprint. Happy to chat more about all of these things. I think it's a very exciting time because all of these are very interdisciplinary. It's very human-centered, it's very AI-centered, and it's very system-centered. So it's super fun.
This is fascinating, Shreya. So just a couple of clarifications. So this focus, is it specific to unstructured data or is it both structured and unstructured?
The DocETL project currently is mainly focused on unstructured data. A lot of our optimizations, I think, can port over to the relational world. Like there are semantic relational operators, like a semantic projection, where you have an LLM call per tuple in your database. And I think those can benefit from the same kinds of optimizations that we think about. But there's a future where we're going to do all kinds of data. It's just not today.
Got it. Yeah, so we'll just stick to unstructured for the purpose of this conversation. You talked a bit about optimizers and prompting, and you mentioned things like accuracy of prompting. As a layperson, leveraging prompts, like whether it be with ChatGPT or the other interfaces, I've never thought about my prompts as being accurate or not. Can you unpack that a little bit? When I'm talking to an LLM, I'm prompting, of course, I have a certain goal and outcome in mind when I'm trying to ask a certain question, but I've never thought of is it even right to think of this as accuracy, I guess, when you have a human doing the prompting?
This is a great question. There are not super well-defined notions of accuracy, but there are plans that are more and less accurate. Let me give you an example. So imagine I have a transcript of information, like a conversation between people, and I want to extract all instances where somebody asked a question. Now, there is a more accurate answer where I have extracted more questions. There's a less accurate answer where I've only extracted one or two questions. Now, there's this world, there's no ground truth. Nobody has labeled the data of these are all the questions. But we find that when documents are very long or tasks are complex, like maybe a task like asking for a question is very simple, but asking for a specific type of question, like we work with journalists and they're interested in specific types of data. They're interested in, mining records, police records for instances of misconduct. We talk about this in our paper. Misconduct is a difficult task. Nobody knows what that is. So you can imagine that when you just ask an LLM in a 100-page document, give me all instances of misconduct, is going to give you maybe 10, but you would rather have the plan that gives you as many as possible. So that's what I mean when we say we rewrite queries for higher accuracy. There are ways where you can break that task down into smaller subtasks. Maybe I can extract on chunks of the document and then unify the results together. Maybe I actually break down the task. Like extracting misconduct is a task. Maybe I break it down into excessive use of force and like bribery, two different types of misconduct, and I have an LLM call per type. Right, so that you can think about the number of ways in which we could rewrite prompts, rewrite operations, whatever you want to call it, that all have different accuracy plans. And yes, it is fuzzy in that I can't say that this is 98% accurate, but you can come up with plans that are more and less accurate than others. And that's what we find that users really need to do. That's what they spend most of their time engineering themselves, like what is the right level of decomposition. So if our optimizers can kind of bake that experimentation process into them, then that ultimately leads to better utility.
And these are prompt optimizers that you're referring to?
We call them operation optimizers because if you want to call them a prompt optimizer, I think you can. I think there's just a lot of literature. There's strategies for how you do prompt optimization, but you can think of us taking a prompt and breaking it down into multiple different prompts. We don't try to reroute the prompt to be a single prompt to try to do everything. The strategies for prompt optimization, right, are like few shot examples. That's the common strategy, but that doesn't work in a data processing case. You cannot have 10 big documents in a prompt. It will exceed the context windows. It will distract the LLM. We have just a different optimization game we have to play all together.
Got it. So I was wondering if you can touch upon the context of benchmarking. I know that is an area of research you have. Given what you just mentioned, it seems like this is a task that, if I port over the function of data engineering to the unstructured world, a lot of the tasks that you're mentioning, like whether it be looking at large document and trying to extract examples of police misconduct, that could very well be a data engineering task. Could you talk a little bit about what is the concept of benchmarking, like benchmarking around prompts, especially when it is thought of in the context of a job that a data engineer might want to do?
Totally. I think benchmarking is very hard to do in this space precisely because you identified accuracy is fuzzy. It's not well defined. It differs from person to person. So there's no ground truth. One journalist might be interested in a specific kind of misconduct. Journalist B might want another type of misconduct. And it's not that their prompts are wrong or right. It's just is. It's a fuzzy task, and this is just the world that we live in. So when I think about benchmarks, I think about how can we incentivize the research community to come up with better plans for executing pipelines. So maybe it is treating a model, an Oracle model, as ground truth, whether it's a human or GPT-4. And then can we come up with a benchmark that forces users to use GPT 3.5 or 4.0 mini to try to kind of match that Oracle performance, with the hope that, maybe along the way we uncover decomposition strategies or we uncover a way to search over plans that we can then write into optimizers. So I think benchmarks are good for guiding progress, but they're going to be fundamentally different in this new area. They don't have ground truth anymore. So we have to be very thoughtful about what it is that we want to measure and how we will make steps towards that. We want better search. We want cheaper plans. So how can we move towards that world?
And Shreya, if I were to try and extrapolate some of the benefits that people might see down the line from the line of research that you're working on, is it fair to say that maybe one outcome could be that a lot of the manual steps that are currently required to extract knowledge out of unstructured databases, that becomes at least semi-automated? Would that be possibly one outcome?
Totally. And I think also the work that you need to do in data engineering is going to be different because now we can do fuzzy tasks. So the work that comes around building a pipeline to extract misconduct is going to be around making sure you've defined misconduct correctly, which is an iterative process with the LLM. Right? You look at what the LLM says when you ask it for misconduct. You realize it has a different idea from you. You realize, it flagged something you didn't expect was misconduct. You change your prompt, and this is a process, right, that you do to figure out what you want. And I think this is going to become a huge part of data engineering in the future. So maybe less toil around writing the code to come up with the chunking or whatever that a data engineering person might do today. Manasi probably knows very detailed what data engineers in Gen.AI are doing right now. But I would love for us to move towards a future, right, where it's less about this toil and more about, okay, how can we enable people to do very hard tasks, and what workflows are they going to have to do to be able to get there?
Mm-hmm. And I think you're also alluding to some of the maybe reasons that Manasi touched upon as to why enterprises are struggling to get their prototypes into production because of all this toil that probably people don't anticipate getting into these projects in the first place. And there's obviously fascinating work that folks like yourselves are doing, but not to be outdone, companies like Manasi's at Cloudera, they're also launching AI co-pilots. And it seems like, at least to me as an outsider, a big part of what they can help humans do is to reduce the kind of toil, even while using an existing data product, like in this case, maybe Cloudera's. Mm-hmm. So as we zoom out a bit and think about other tasks beyond just data engineering, like say in data ingestion, storage, transformation, data integration, modeling. I mean, there's just a lot of data management tasks where there's toil involved. What are some things that come to your mind, Manasi, where things can potentially get a whole lot simplified with GenAI?
Great question. And I kind of agreed. I was nodding along as Shreya was talking about their work. To me, the biggest lift that I hope we'll see is making access to data and analytics a whole lot easier for different kinds of users, where the simplest one is natural language to SQL. You don't need to write SQL to get your questions answered. And there's a whole category of folks who can't write Spark, who can't write SQL, but they just want to get their jobs done. And if we can go from here's the description of the task that I want to do, there's a system that's taking that prompt, making it better, figuring out plans, and then giving you an answer. That's to me the holy grail. That's what I think all of us are trying to get towards. That's the part that I'm most eager to see come to fruition and come to life. There's a really interesting, again, user experience component to it, which I characterize as it's much less about creation now. It's more about review and that iteration. And how do we make that easier? Because now we're instructing this machine to do a particular task, and we're not so good at describing what we need anyway. So, how do we help the humans get better at describing what they want? And then for the machines. So I'm most excited about expanding access in really interesting ways. And there's a lot of the components that have existed for a while, whether it's data catalogs that collect a lot of metadata, query optimizers, they're going to get rewritten and integrated in really new and interesting ways that I don't think we've imagined quite yet. So super excited for that.
Yeah, it's super interesting. And I think it's a very interesting time to be building products because there is a sense that everything that's been built before is going to have to change, just given the way how we are interacting with machines is going to change. Shreya, follow up to you. So this is on the topic of general purpose coding assistance. So like Manasi was mentioning, it seems to be less about creation, and this is where coding assistants come into play. What is your view? And given that your vantage point is specifically focused on data and data engineering, maybe data management, I'm curious to hear what are your thoughts on general purpose coding assistants becoming more applicable for broader tasks? Or do you think that they're not going to become good enough, at least in the near to midterm, let's call it now to like 3 years, in all kinds of tasks? Like, should general purpose coding
Yeah, it's a good question. I use coding assistants every day. Right? I'm a researcher, so I don't have to worry about my company disliking Cursor or whatever. I can use Cursor. I can use Windsurfer. I don't know even know the names, but I've used them all, and I use Cursor every day. And I think where this is applicable for me is we have a IDE for DocETL, where domain experts, people who don't know how to code, are writing DocETL pipelines. So you can think of this as LLM pipelines over their data to do document analysis. And there are several Copilot-like features that I'm building that I think are very useful. One is in helping people come up with prompts for their operations. I'm very surprised at how useful our features are for domain experts who wouldn't kind of know how to write these prompts. Prompts are, in my sense, they're code. They're Jinja templates for us. So you have to understand what is the semantics of a map operation, what's semantics of reduce, what's a for loop, if statement, these things people are understanding because you can have coding assistants teach this to them well. Like we have a very structured flow in which you purposefully write an underspecified prompt, going back to Manasi's point about fuzzy prompts and whatnot. People purposefully start out with an underspecified prompt. We run it on their data. We give them a view of their data with the LLM response. We ask them to provide feedback on the LLM response. Then we take them to a place where we use that feedback and suggest changes to the prompt. Users can interact with that assistant, coding assistant, very akin to Cursor, to iterate on that prompt. Say like, no, actually don't add this new instruction, or rephrase your instruction, add an example of this type of instruction. They get a new prompt and they go through the cycle. And I think you cannot do that without coding assistance. You cannot do that without treating this as code and just an iterative process. So maybe this didn't fully answer the question you asked where, are people going to use general purpose coding assistants? I think they're going to use coding assistants in every IDE. And it's just that the IDEs are going to change. Now, domain experts, they might not be writing Python code. It might not make sense for them to do that in, IDE like VS Code, but they're going to write it in DocETL or the DocETL for whatever domain that they're working on. And all the same AI assistant principles are going to be there.
That's fascinating. So maybe an example that comes to my mind is if you take Cloudera and their product offering as an example of an environment, it seems like their Copilot or coding assistant would be something that have all the context of everything that is in Cloudera, whereas like a general purpose tool such as Cursor, maybe it could be like something that interplays with a Cloudera environment. So they're not mutually exclusive, it sounds like, or it isn't like Cursor will displace the need for something that is more environment specific. It's
Absolutely.
kind got
Yeah.
it.
I think it all goes back to a user-centered take or human-centered take on users. Like people who use cursors, who use coding IDEs are hackers, they're engineers, that's their persona. They want to be able to build anything and everything. Domain experts who don't want to be programmers, who don't want to be hackers, it's not to say they don't want to benefit from a AI assistant or copilot, but they're not going to use cursor because they don't want to write code for like all sorts of different applications. They want to use it in Cloudera. It's going to be all the same features, all the same interaction patterns, but it doesn't have to be the same tool.
And going back to the topic of benchmark that we were discussing a few minutes back, Shreya, so that notion of benchmarking, so how should we even think about benchmarking general purpose coding assistants then?
I'm not the person to ask. I feel like there are
You can have
many
an
people
opinion
thinking
though.
about this problem, and I have very strong opinions that we are so far from anything. So this goes back to my earlier point about benchmarks traditionally and historically have been about achieving accuracy against a single ground truth. When AI, we're moving to a world where there's no ground truth and we need to redesign the idea of a benchmark. So all benchmarks today, even the coding assistant benchmarks, are trying, there's a ground truth pull request merge. And that doesn't make sense to me. Like you can have all sorts of different plans for a good tackling an issue, right? So you want to come up with how to better search the space of possible outcomes, how to better interact with humans or have humans in the loop. These are not measured in the same way as having a ground truth gold label and then computing a difference against that. Yeah, I have yet to see a benchmark. We haven't built a benchmark just because I feel like we don't know what it's going to be like. Still very much thinking about it.
Makes a
Yeah,
lot of
and I
sense.
would add to that saying like there's benchmarks as used in various different ways. There's benchmarks for models, and then there's like task specific evals, which is kind of what we're getting to. And even in the community, folks are really confused with like, oh, GPT works better for, in this particular leaderboard on Hugging Face. And usually my response is, well, that's nice, but you gotta test it out on your particular task and your particular data and how it works. So to Shreya's point, is like there isn't going to be a single one. There's going to be like test cases for your software. They're very specific to your software, and those don't even involve the human in the loop. So we absolutely agree. Like we're rethinking and need to rethink what benchmarks are.
Yeah, it's absolutely fascinating. I mean, if there is anything that I have taken away from this section of the conversation, it is that the ground truth is there is no ground truth. So
Makes it
that's
very hard.
fascinating.
Makes it extremely hard to be writing papers right now, actually. Yeah. I
Wow.
just cannot get myself excited about solving a benchmark now. Knowing what kinds of tasks that people are using docETL for and how these are real world, very interesting tasks, like making sense of police misconduct or annotating law articles, things that are just by nature, like you couldn't do without docETL or LLMs or whatever. It's so hard to now try to solve a benchmark that I know is not reflective of that kind of pattern.
Absolutely. Switching topics to something that seems to have been our favorite here, which is on user experience and HCI. Manasi, you talked about your experience on this late last year when you were still working on Verda, and there were some interesting considerations you were chatting about in terms of designing applications that leverage LLMs. Could you talk to us a little bit about how you think developers and even product managers, as they're thinking about planning and designing an application that leverages LLMs, how should they be thinking about user experience and HCI? What are some best practices or even like pitfalls that you think folks should avoid?
Yeah, this is such a broad and super exciting question. So I think we're going to talk a lot about it. To me, the single most important aspect of making GenAI useful is the UX, very broadly, user experience for it. The technology is going to keep getting better. The models will keep getting better, so on and so forth. But the thing that we haven't quite figured out is how do we let humans, ask questions of the system if they should be asking questions of the system? How do we present answers in a way that the human can make sense of them and then make the system better over time? And the personas that are now using GenAI are just so broad, it's mind blowing. There are the builders that are building, even like SQL builders. I want to ask a question of the data and then I get an answer. That's one category. I work with different teams within Cloudera that want to use AI. For them, the legal team, like the prompts are still several layers deeper and they will never interact with it. Or our recruiting team that just wants to use AI to filter resumes, they're never going to go that deep. So there's different layers of user experience depending on, are they end consumers, are they builders? And so the UX is changing. So it needs to be necessarily very different at these different layers. The key points that I keep coming back to is, how do we transition from we're creating things? If you think about the legal case, how do you transition from I'm going to write an NDA to I'm going to review an NDA and make sure it adheres to our requirements? That's very different. And how do I do it at scale? Because now when you're writing it, maybe you're giving it more attention versus if you're just reviewing dozens of these things, your attention is going to decrease. And you might be so-called lulled into a sense of, oh yeah, this works, until it doesn't. And so there's a different kind of review interface, and that's very much tied to how do we make this iterative for humans that are using it. I think that's just fascinating and a problem we need to solve. Or even in the SQL case, as with every company, there's different applications of GenAI, whether it's going from a particular version of a database, which has a SQL dialect, to another version. Now you might be rewriting a whole, thousands of queries to work with this new version. How do you quickly enable a SQL developer to triage these things and tell you, okay, this makes sense, this doesn't make sense, without causing fatigue on that person that's going to ultimately lead to accuracy issues? So I would say, to kind of summarize, depending on the persona, the kinds of tasks are very different and the personas has just exploded. So we need to think more. And then how do we get to this iterative review feedback interface versus creation from scratch? I think those are fascinating and open problems that as a community we're trying to solve.
Thank you for sharing those, Manasi. Makes a lot of sense. And especially, something that you mentioned a couple of times, the delineation between creation and review, that keeps emerging too. And it seems like a design pattern almost that has to be front and center when UX is to be considered. And Shreya, you've done some fascinating work here. I've read a couple of your papers, and tell us something about some of the key challenges and learnings that, based on what you've seen, developers should keep in mind when they're thinking of embedding LLMs into their applications.
Yeah, I agree with everything Manasi says. I've started to think about this problem, though, from the perspective of design research. I'm not a design researcher. It's a huge community, but I'm learning a lot from them, and also like design philosophy, like thinking about, how our philosophers thought about tools and how people should use tools. Tools being an extension of yourself as a human. So if you think about, I'm going to get very philosophical, so you have to bear with this. Imagine that the AI is a hammer with unknown shape of a head, and you kind of know fuzzily the nail you want to hit, and you don't know what the shape is of the hammer. And when you hit it, there's also some randomness in where the hammer moves. So of course, there's going to be iteration involved. You're not going to get it right on the first try. And the goal is, how do you help people hit the nail that they can't see, and the hammer that they can't see, but eventually be able to do this quickly and fast. And the AI is that hammer for you. So I think it's much easier if you're trying to use AI in your tools. If you're an AI systems builder, if you can make assumptions about the nail, this is very nice, because now you can design a flow for that. In many problems, you cannot make assumptions about the nail. So you have to design a different kind of flow. But I think what's front and center that I don't see tools realizing is that people are treating AI as separate from the human. Like there's a separate generation process, separate review process. That is very hard for me to conceptualize, because that implies the user has to make that transition between the two, but they should not have to. I know it's easier said than done, but this is just from a philosophy point of view. How can we have one amorphous flow for them? I don't know how to solve that problem, but we're really working on it.
I love that analogy. It's like everything is fuzzy. I love it.
Everything is fuzzy. And I was also going to say, I started conceptualizing to the point where I started thinking, man, I better know where that nail is versus me because I don't want to use that hammer to hit myself. So, but this is fascinating. And Shreya, to bring it to something more immediate, a lot of people like Manasi was saying, they're building RAG-based applications, using a lot of prompting, human in the loop. What are some things that people should do as they are prompting these LLMs as part of their app? Like how much human in the loop, how much visibility do you think people should provide an end user?
Yeah, it's a difficult question. I think successful users of these Gen AI tools understand that they have to solve for failure modes that may not exist a year from now. So they have to look at their data. They can't use the tool as is. When, for example, if you want to edit your prompt because it's not quite right, you need to look at many samples of your data. You need to put a data science hat on. You need to figure out what part of your feedback is actually generalizable to your data set versus, just specific to that example. So maybe it's not even worth telling the LLM to focus on that use case. You need to do all of this work because the tool won't do it for you. The AI should do it for you because it is your tool. It's an extension of you. We are going to move towards a world where it can, but you simply have to account for that shortcoming. I think a lot of the success that I've seen today for tool use is just education based around this, unfortunately. Like teaching people what are RAG patterns? What are RAG failure modes? How do you look at your data? Step 1, do this. Step 2, like annotate, thumbs up, thumbs down. You even have to tell users to think whether output is good or bad, and then think about why it's bad. I feel like with such early stages of this, and like education might actually be the best way to solve a lot of the today's problems before we can figure out how to actually design a truly human AI collaborative solution.
I want to plus one that, whether it's content writers or even coders, how to use these tools effectively. We need training for the masses on how to be more productive with AI. And I think there's a generation of startups and companies that are going to do that, is how to be a more effective marketer with AI. Those are real skills you need to learn. So there's a real opportunity there as well.
Yeah, extremely well said. And that's a great place to wrap up this podcast too. And I just wanted to say one other thing, which is that the beauty of all this is that, like Manasi, you started by saying one of the things that you think where Gen AI seems to depart from machine learning and AI is that things are way more accessible than they used to be in the previous iterations of AI. And that is the opportunity for all of us to get more educated by using it, by being part of the creation and the review process here. So this was an amazing conversation. I truly enjoyed it. I'm sure our audience will have tons and tons to take away from this conversation in terms of learnings. Thank you so much for your time, Manasi and Shreya.
This was super fun. Thanks so much. This is one of the most exciting times to be working in AI. So I'm just thrilled we get a chance to do that.
Awesome.
I agree.
Thank you so much.
Thank you for tuning in to this episode of the Enterprise GTM Podcast. Subscribe to the show wherever you listen to podcasts so you'll never miss an episode. While you're at it, if you found value in this show, we'd appreciate a rating on your favorite podcast platform so we can continue to help enterprise founders thrive.